Hi, folks. Thanks for joining us. We're live again in StewMac studio, continuing our 5-watt 57 mini Tweed amp kit live build along series. This is episode 4 of the series. So if this is your first episode joining us, welcome. If you're joining us again, welcome back. Last episode, we populated our eyelet board and prepared it, got it ready to install. Which today we're going to be installing it into the chassis, which we prepared in episode 2. And by the end of today's episode, it will look something like this. Or that's the goal anyways. Yeah. So we have a lot to get into today. My name is Pete. Joining me as always is Tommy Stumpp.
Good to be with you. We've got Rachel.
Hey, y'all.
And Susan here.
Our director, Susan.
Howdy.
All right. So before we get into the work today, I think we should go over some safety tips again.
Yeah, definitely. So as always, we have to mention if you're working in a live amplifier that is having been turned on with tubes in it, you need to follow some important safety precautions anytime you're opening the chassis. So we went over all of this in episode 1 about how to use a multimeter to confirm that your filter caps are discharged and how to discharge them if they're not using a snuffer stick. But we really need to harp on this every time because we're building an amp kit. We're not building a ukulele kit. Amp building always involves high voltages, and you need to just have the best possible habits in place before you start really getting into this.
Right. And so what are some of these safety tips that we really want to harp on?
You want to make sure that you're not overly tired. You want to make sure that you're wearing rubber-soled shoes. You want to avoid having any metal jewelry on. And you want to, like I said, discharge those filter caps. That is the biggest one for sure. But other than that, just, make sure you're not uncomfortable, well-lighted area, things like that.
Yeah, and stay suspicious. If you're not sure if the amp had power to it last time you checked, just assume that it did.
Absolutely. And again, for our purposes, this amp is not going to have any voltage in it until the next episode when we start testing it.
And for anyone following along in the instructions at home, you can always review these safety tips on page 6.
Absolutely.
All right. But I think it's time to get right into it. We have fewer steps to cover today than our previous 2 episodes, but they are jam-packed full of different tasks.
Yeah, there's a lot to do, so let's jump right in.
Yeah, so we're going to be starting on page 21 of the instructions on step 49.
Right on. So if you remember, we prepped our eyelet board and insulator board. We've got our eyelet board fully populated, and we've got our insulator board that we already drilled our mounting holes through. So first, we're going to get that insulator board in place. What I like to do is use some type of tool like an awl or a soldering aid, something with a point to act as kind of a registration pin for the insulator board. So what I'm going to do is just slide that in under those components that I mounted into the chassis. Then I'm going to use that sharp tool to get through the mounting hole and act as a registration pin. So I like to do that on both of them. And then you're sure your board is in the right place and you're sure that your mounting holes are in the right place. You want to do that because if you gotta re-drill holes, it's better to do it now than at the end. So then now that I know my insulator board is in the right place, I'm going to lay my eyelet board on top of it. So now this can be tricky. So I'm going to bend these leads up. And there is one more step before we get all the way installed. And that is to make sure those leads that pass under the board are the lengths that we want. So in the instructions, it says hole 1, you need at least 2.5 inches for that green. And I can see I'm around 3 inches, which is just fine. And then for hole 15, I want to make sure I have at least 3.5 inches. So that's here. And that is good to go there. And then for hole 4, we want 2.25 inches. And if you do hole 4, you don't really have to do the other hole 23. But it's not a bad idea to just check. So I've got approximately 2.25 inches there and 2 inches over here. You can still adjust a lot of these once they're in the board. It's just good to do that ahead of time just to make sure you didn't make any drastic errors with those behind the board jumpers. So what I'm going to do with this still in place, with my insulator board still in place, sorry, I'm going to feed this in underneath those components. This can be a little bit tough to get this squinged in here, but everything should be pretty much secured in place, so you're not going to damage anything getting it installed. And once it's roughed in, I'm going to put this in here again as a registration for that mounting hole on this side of our chassis. So I've got that through there, making sure those boards are lined up. Then I'm going to get the screw installed on this side first. The board sits over a nut, so there's a little bit of a curve to it, and I find it easier to do the side next to the power transformer first. The other side sits closer together, so it's easier to get that screw through both boards once the other one is in there. Otherwise, you have to kind of push this side down if you do that one second. Just a little tip for our instructions here.
It's a good tip. So Tommy, we discussed pretty in depth what the eyelet board is doing, and when we populated that in episode 3. But what exactly is the insulator board doing that you just installed below that?
It's stopping your solder connections from touching the chassis, which is ground. So for this step, for the mounting, I've got my 632 1/2 inch machine screw. There should really only be a few screws left, and another locking nut or Kep's nut. And I'm going to just pop that through the mounting hole there.
So for those of you who may have joined us for previous episodes, this episode is going to be a little different. As you can see, we're installing the majority of these components into the chassis. It's going to be very, very tight space. So what we'll try and do is to show you, tell you what we're going to be doing, and then it's almost impossible to give you a shot of that while it's actually being assembled or soldered, whatever the task is that we're doing. So once we actually complete it, then we'll go back and show you exactly where that connection was made.
Right. Thanks, Pete.
No problem.
So what I'm going to do is get that screw through and then flip it over so I can see where I might need to adjust it to get it popped through the chassis. Now you can see it's nice and popped through. I'm going to get my locking nut on there. And this part can be a little bit frustrating. Just take your time. Don't give up. You'll get it. I'm going to tighten that down pretty good. You don't need to bear down too hard. But there we go. And I can see in my chassis that mounting screw isn't going to touch this lead of that filter cap. Super important. This is going to act as a ground, and you don't want this lead to go right to ground. You're not going to have any B+ voltage for your circuit. So I'm going to go ahead and get that other bolt, that other machine screw through on my other mounting bolt.
Right, and I'll take this opportunity to remind folks we are shooting this live, so you can ask us your questions and get an immediate answer, while you're building along with us, or if you're just tuning in to watch, to join.
Quasi-immediate.
Quasi-immediate.
You might be
Perfect.
talking about something. So again, I'm just doing the exact same thing on this side of the board. Getting that screw, pop through that hole. And like I said, this side should be pretty easy. You can see that. I don't know if you can see that, Rachel.
I can.
Cool. That bolt just poking right through. Get that lock nut on there. Again, you don't need to bear down. Once you feel a little bit of tension on the screw, you're probably good to go. So there we are. We've got our eyelet board mounted nicely and securely in our chassis. We're ready to start making all of our front panel connections.
All right, yeah, so moving right along onto step 50 on page 22 for anyone following along in the instructions.
All right, so we're going to start with our lamp socket. We're going to connect the last two resistors from our kit, our components box, to the lamp socket. We're going to twist, so here are those. We're going to twist one lead from each together, and then the other two leads are going to get connected to the socket. So we're going to do a little bit of soldering here. What I'm going to do is get my helping hands. Again, resistors don't have polarity, so it doesn't matter which way they face, but I like to make it match the instructions, so we're going to go ahead and do that. So if you can see that, Rachel, I'm just twisting those together. I'm going to hold it in my helping hands here. Is that a good shot?
Yes, it is.
Far out.
So Tommy, while you're doing that, we got a quick question here from Frosted Head. Does the kit include the death capacitor?
No. So back in the day, they didn't have grounded outlets. They didn't have a safety ground on every outlet. So there's a capacitor wired in a lot of amps in tandem with a ground switch, so that if you plugged into a given outlet and your amp had hum, you could hit the ground switch and essentially flip the polarity. The death cap was designed to, I believe, pull some of the noise out, but if it failed and failed open, it would send all of your wall supply, your mains supply, to the chassis and theoretically through to your guitar strings. So really a bad design and completely out of date today. So there are a couple things that deviate from the original spec. If you wanted to use that death cap, we don't recommend it, but you can find caps called Class Y caps. I'm going to just solder this while I'm talking, that are designed to fail closed. Sorry, fail open. I said it backwards before. If it failed closed and connected to circuit, the death cap, I mean, it would send all that voltage to your wall, to your chassis. So I've got that soldered together. Can you see that, Rachel?
Mm-hmm.
It's nice and shiny. I'm going to wrap these legs through the pilot lamp socket. You can do it however you want, but eventually they're going to connect. I don't know if you can see that, Rachel.
Mm-hmm.
They're going to connect to this this green leads. So I like to have it somewhat in a way that it just makes that easy. Sorry, it's going to connect to a green jumper that we haven't run yet. These green leads also connect to this socket. Losing it.
All right. So are you going to connect the resistors to that jumper first, or are we connecting?
I'm going to connect the jumpers or the resistors to the socket, and then I'm going to connect them to the jumper, which is also going to connect to ground.
Right. And after Tommy gets those nice mechanical connections installed, we'll go ahead and give you a good shot of that before soldering it.
Exactly. So I've got my resistors wired and fed through the same leads on this socket. And this lead is long enough that I can put it wherever I want, but I just want to make sure I have a little bit of room here in case I need to adjust the location on these. And I'm going to go ahead and solder that right now. That's not exactly how the instructions say to do it. I just find it works easier. So I'm going to go ahead and just finalize that connection at the lamp socket on both tabs.
All right. And while you're doing that, we did have a question in the comments after episode 3 was posted to our channel. Hibernative asks, is this safe for someone who has only changed pots and pickups in guitars?
Yeah, so these instructions have copious safety information all around. And if you can follow instructions, you can build this amp. It sounds like the commenter has some experience soldering, so that's a good sign. Again, you need to be able to solder, but we do have tons of tips on soldering, both in the instructions and throughout these video episodes. So it really is safe for pretty much any skill level to build this amp. So for the next part of this step, I need to solder a green jumper to the twisted leads of those resistors. This can be a little tricky just due to the small space over here. If you can see there, Rachel, I need to get that green jumper all the way down in here. If you can see that terminal strip down in the bottom of the amp.
Kind of, it's hiding.
Yeah, it's hiding. So what I'm gonna do is loosen my fuse socket. I don't need to unsolder it or anything like that. But if I loosen that nut, I can pull that kind of back through the face of the chassis. And then I'll have the access I need. You can wait to solder the fuse socket as well, if for people who are not building along with us. But if it's already in there, I recommend pulling that back. And you can see now, I can see a great view. And again, what you're seeing is what I'm seeing. So if I can't get to it, if the camera can't see it, it's probably not going to be easy to do. So having that pulled back is a nice little tip. I'm going to get my green jumper fed through that grounding strip. And I want to put a little bend on it again, because as we keep saying, good mechanical connections end up with good electrical connections. So I've got that. I don't know if you can see that, Rachel, but I'm tipping it just so it stays in place. And I'm going to get my soldering iron down in there.
Now, Tommy, does it matter which of these lugs on that terminal strip you're soldering this connection to?
It doesn't. If you remember when we created those, they all are connected together. So this is just one terminal strip. All three of these lugs are connected, and they're all connected to ground. So I can feel that's a good connection. Another useful thing with your chopstick is to check your physical connections. I can pull on that and it's not going anywhere. I don't know if you can see that, Rachel. Mm-hmm. That is another reason this is just an indispensable amp tool. So I was able to jiggle it free, so I need to just fix that. There we go. All right, so I'll pull that insulation back, if you can see that, and I'm going to wrap that onto these leads. What I like to do is kind of twist them around each other if possible.
So, Tommy, what are the what purpose are these resistors going to this lamp socket serving?
They are stopping any like transient voltage, stopping noise or oscillation from getting into your heater supply. It's just so you don't have a floating ground, essentially. Just not every amp has the same setup for grounding the AC supply like that. And I'm going to trim that extra bit of lead off here. So you can see that's a nice connection there to ground, and that's looking pretty good. I'm going to trim these extra leads at the socket as well.
It's not vital that you have flush cutters or that you get totally down to those solder joints. You don't want to damage the joints, but it'll just help it look nice and clean like that does.
Now, Tommy, when you're trimming these leads after making these connections, is there anything that the folks at home should be aware of or cautious of?
Regarding trimming the excess,
Yeah.
don't break your solder joint. Don't cut it until after it's soldered, things like that. So for this step, I'm going to wrap these two green leads into the outer lugs of my lamp socket. You can see on these kits, it's pretty nice. They have two leads on the lamp socket as well as the tube sockets, except for the 12AX7. So it makes wrapping leads easier, and you can kind of solder some of these as you go.
All right, so we're on to step 52 then.
Yep, we're just wrapping that into those lamp socket eyelets.
Mm-hmm. And this is the twisted jumpers that we had coming out of hole 1
Exactly.
that we installed in episode 3.
Yep, and I'm going to just bend those down so they pinch on that a little bit better. And I'm going to solder them.
All right, and a reminder for anyone who may have just joined the stream, we are live, so we can take your questions and answer them as soon as possible. So please feel free to ask any questions in the chat.
So now we've got that soldered there. We're good to go. I'm going to just kind of bend that out of the way. And we are on to the next step.
Can you show us how you bent that with the chopstick so we can get a better
so
view?
I just pulled those back out of the way so I could still have access to some of this other stuff down here. Nothing tricky about that. And again, this is just an AC supply. So you want to make sure it's twisted nicely, that we already did, and that it's not just too close to any of your signal leads, which we'll talk about in a few steps. What's our next step, Pete?
We're on to step 53 already.
Nice.
We're going to solder the 2 volume pot connections.
Okay, so our volume pot is also our power switch. The power is on the back. The audio is on the top. So our 2 audio connections coming from the preamp tube are the one that we marked in black, as well as this yellow one over here. We want to keep these away as much as possible from this black connection down here that's going to take the power. Anytime you have power and audio crossing, they can interact and create hum. So I'm just going to peel that back, wrap it into the volume pot. And I see that I don't have quite as much as I want on this black lead, so I can't dress it exactly how I'd like. So I'm going to kind of feed some back through. Depending on how tight you have your mounting bolts, you may need to loosen those a tad to get this to move through. But you can see I was just able to feed it through under the board because it's not connected on either end. So I'm just going to wrap that into that lead again, into that lug again. Is that a good shot, Rachel?
Yes.
All right. And I'm going to solder it, and then I'm going to worry about lead dressing. You don't need to worry about lead dressing until after it's soldered, unless you don't have enough cable, and then you do need to worry about it before it's soldered.
And can you elaborate a little bit exactly what you mean by lead dressing?
Sure, I'm going to show you right now. So you can see I've got this joint made, looks good. And now I've got my lead, but it's kind of all over the place. I don't really care for how it looks. So what I'm going to do, you can use a chopstick, you can use your fingers, is peel this lead back and route it so that it stays as far away as possible from my black lead for the power for this pot. So I'm going to pull that black lead down and keep it along the face of the chassis
And I'm going to pull my yellow lead so that it comes up and away from that black lead. And now we'll connect our other one. We don't need to worry so much about this one since it's not going close to any of our power connections over here. I'll wrap that through that pot. Bend that over a little bit. And away we go. That looks like a nice connection. I'm going to go ahead and trim those excess pieces.
And that'll wrap up step 53, right?
Yeah, I'm just gonna route that back on the face of the chassis just for tidiness. Nothing too crazy there.
And for those following along in the instructions, you can see on page 22, you can sort of follow these paths with the wire in the instructions as well,
Right.
that Tommy's demonstrating.
Yep. And those are just the input and the output from your volume pot. So there we go. We're on to the next step.
And which one's which, Tommy?
In is the one without the black.
Great. So yeah, step 54, we're going to connect the input jacks.
Yep. So we've already got that resistor wired on jack 1, which is our high jack. So all we have to do is connect the 2 yellow leads that are going to carry your signal and the green lead, which is going to carry your ground. They're all grounded through the same connection on jack 2. So I'm just going to go ahead and do that now. We're going to connect the jumper from pin 9 to the bottom lug of jack 1. And that is going to be a little bit tight, but it should be long enough as long as you followed the recommendations in the instructions.
And so something that we discussed in episode 3 when we were populating the board is sort of this process that we want to make sure to really hammer into your minds here is we're going to wrap the components, then we're going to inspect, and then we're going to solder. So you may notice that the resistors in those lugs of the input jacks are not soldered yet. That was something we did in episode 2, and it wasn't time to solder them at that point because we were going to be adding these leads and we want to solder it all at the same time.
Right.
So we'll get to soldering it after Tommy wraps it and
Right.
inspects it.
And the other 2 leads on jack 1, you could have soldered those. It was just when we made the instructions, the idea was to solder everything all at once. So you're not forgetting anything. You're not going back and forth. So I've got my lead 9 wrapped. Now I'm going to wrap the lead from eyelet 10 onto the right lug of jack 2 with the tip connection.
And Tommy, I had a question for you while you're doing that.
Go ahead.
Why do we have 2 input jacks, and what does it really mean to have a high jack and a low jack?
So the idea was in the 50s that you could plug multiple instruments in to the same amp. And the design is such that they won't interfere or interact due to these 68K resistors down here. Those serve multiple purposes. They are mixer resistors, so the inputs don't interact with each other. They're also grid stop resistors, meaning they stop excess noise. And they also set the input, they act as a voltage divider to make input 2 essentially half the volume of input 1, minus 6 dB. So they, in the 50s, the idea was you could plug a louder instrument into jack 2
and a quieter instrument into jack 1, and have more than one person in the same amp and need less equipment. Not used very commonly anymore these days, but certainly still a possibility.
Certainly interesting too.
So I've got my jack 1 all wired. I've got every connection made and just double checking everything visually. So I'm going to trim those excess leads. And now I'm going to I'm going to solder my yellow lead. It's at jack 2. Sorry if that's not a great shot, Rachel.
Is that right? You can do it after.
Cool. That guy looks good. I'm going to trim it. And we'll go ahead and add our green. Which is ground. I'm going to bend that so it gets in the right shape for me.
So is that the jumper from eyelet 11?
Right. And you can see I just put a little hook on the end so I can hook it through there and it'll stay in place while I'm soldering.
All right. So for anyone following along in the instructions, we're now on to step 55 on page 23.
That's a nice shiny connection. It's spread out onto that tab. I'm pretty happy with that. And I believe we are on to the next step. So you
We've
can
got
see-
one more eyelet or one more jumper in this step,
Oh, yeah.
right? From eyelet 2.
Yeah, you got it. Good call, Pete. I'm going to go ahead and put my fuse socket back in on the front panel too, just so I don't forget.
Well, is that?
Oh, no, I let
I
two
think-
goes that ground. Yeah,
Yeah,
you're
I
right.
think
Good
that's
call.
why we left it off,
I'm
right?
glad you're here, Pete. So this green jumper goes down to that same terminal strip that's buried down in the front corner of that chassis. So this green jumper from eyelet 2 is going to go down to this ground strip. This is a crucial ground connection. It's the ground bus for all your filter caps. They're all grounded, connected together to that one spot. So it's really important that you get this guy connected properly and a good reliable solder joint. You can see this can be kind of tricky getting it down in there. So I'm using pliers or whatever I have around to help me feed it down into that last tab on my terminal strip down in this corner.
And for anyone who's just joining the stream recently, I said it earlier, but I'll reiterate. This episode's a little different than previous episodes because of how cramped the chassis space is, the space we're working in. So what we'll try and do to the best of our abilities this episode is tell you what we're going to do, and then whether it be soldering or installing, something in some small, tiny area, once we've done it, then we'll go back and show you exactly what we've done so you can get a good view of it.
Yeah, so I just mooshed that guy down in there, finagled it.
A little bit more towards me. There.
Is that good?
Mhm.
So you can see I routed it down under the socket and kind of fed it through directly through. And I still have enough space if I pull this fuse socket up out of the way that I can get my iron in there. I'm going to use a soldering aid to kind of bend that lead a little bit just to get a little bit more security, because that is just about as crucial as a ground connection can get in a circuit like this. That's a safety ground. So we really need it to be in there good. And I'm just pulling that against that tab so it has a little bit more physical connection. Now we'll solder it. I wonder if I can go in there. Are there any other good questions there, Pete, while I'm soldering?
We're not getting too many chat questions this time, but I got a good question here. Where's everyone from?
Indianapolis.
Myself, I'm from right here in Athens. Okay.
The viewers.
Yeah, I think I misunderstood that question. Let me restate that. Where's everyone in the chat from? Sound off. We want to hear where our viewers are from.
One was from Belgium.
Yeah, we did have someone from
Nice.
Belgium earlier in the chat.
Prost.
Oh, can I see that solder gun you just made?
Yeah, so we're all done with that terminal strip finally down here. I've got my ground for my pilot lamp, my filter caps, and my volume pot. So now I'm ready to go ahead and get that fuse socket back in. Is that good, Rachel? Cool. So now we'll get this guy back.
There we go. We got a lot of people sounding off now. We've got people from Finland, Santa Fe, Tennessee, Sassy Cat from south of Wichita.
I wondered where Sassy Cat was from.
Sassy Cat's got a question for you here too. We'll get to in a second. Got Las Vegas, Oregon. Yeah, so Sassy Cat asks, why are there only 3 tube manufacturing factories left in the world? Is it demand, environmental issues, or a combination?
Yeah, there's 4 now, I think, or one is on hiatus. But essentially they all shut down when tubes went out of fashion for everything but amplifiers. You know, they used to be in TVs, they used to be in cars, they used to be in every radio. Nowadays, the most demand is just amplifiers and certain boutique hi-fi amps, like stereo amps that you listen to your records on.
Nice. All right, so that's going to wrap up step 55, right?
Yes, indeed.
All right, step 56, we are going to start soldering the 5Y3 tube socket.
Yeah. So we're onto our back panel connections. I'm going to turn this around so that our viewers can see it here. Rachel can see it. And I'm just going to move some of these connections so it's easier for the camera to see what I'm doing. So we're going to wrap the yellow jumper from eyelet 15, that's just a hole, a through hole, onto pin 8 of the 5Y3. And if you remember, in the episode when we mounted all these components, I marked the sockets, these octal sockets, where pin 1 is. So this 8-pin socket doesn't have any markings on the inside to tell you which pin is which. So this hash mark here is pin 1. So I know that the next door neighbor here is pin 8. And again, as we said, I don't know if you can see this, Rachel. All these pins have multiple eyelets, so it's really easy to wrap another lead onto those sockets.
And so you said pin 8 was to the left of pin 1 when looking from the inside.
Right. Yeah. So they go clockwise if you're looking at it from inside the chassis. So pin 8 is the one with the yellow lead closer to the inside of the chassis as opposed to the wall, if that makes sense.
Yeah, perfect.
Great. So I've got that through. I'm going to pull that up so it makes a good physical connection. Another just crucial connection in a circuit like this small, everything's important, but this one is what supplies the high DC B+ voltage to the rest of your circuit. It's what tubes need to function. It's absolutely not going to work if this connection isn't right. So you want to make sure that's a good solder joint. Give it a little tug test. We're good to go there. Now we're going to solder the rest of the connections if we haven't already. We did the rest of those connections when we wrapped these leads, just because there's nothing else that needed to get wrapped. So if you're following the instructions, go ahead and solder those. If you're following along with us, we're good to go on this socket. We're on to step 57.
And those connections, we just soldered that to pin 8, right?
Correct.
Then the other connections are on pin 2, 4, and 6.
Yeah, 2, 4, and 6. And again, this is all power over here, not super important on the routing, but you do just need to make sure all those solder joints are good. This is for the rectifier tube, which is what takes your high AC voltage coming out of your power transformer and turns it into DC voltage that's pulsing, that gets filtered and then passed along to the rest of your circuit. All right, so we are going to connect the red and blue output transformer wires. You may remember we already cut the blue one and wrapped it onto this pin 3 of our 6v6 power tube socket. So we just need to get our red lead and get it to the right length that we want, and then connect that to eyelet 16. Now, we didn't solder eyelet 16 because we had to add this lead. If you made that mistake, it's not the end of the world. You can heat that solder joint up and generally pop this red lead in there, but it's cleaner and a bit easier if you can wait and hold off on that joint. So again, you can see that joint down there is where we're going to go with this red lead. Is that a good shot, Rachel?
Yeah.
And what I'm going to do is figure out the length I want. I don't want it to be too long, but you also don't want to box yourself into a corner. And that's a good length, I think. We'll go ahead and cut that. And we'll strip it back.
And in the interest of fairness and keeping things equal here, I want to make sure to shout out the rest of the people who've chimed in with where they're from. So we've got Benjamin Marn from Ann Arbor, just like Dan, he says. Luther Steves from Denver, Jeffrey Boyle from Philly. And we got EC all the way from Brazil.
Nice.
Thanks for joining us, guys.
All right, so I've got that red lead wrapped onto eyelet 16, and we'll go ahead and do that solder joint now. Is that an okay shot,
That's a
Rachel?
great shot.
Far out. Yeah, need to tune my tip a little bit here.
Yeah, for those of our viewers who may have not tuned in for previous episodes, I know we've mentioned it before, but what temperature do you like to set your soldering iron to?
So it's really personal preference. I generally start at 370 Celsius or around 700 Fahrenheit. And then just depending on the tip, the iron, the project, go up and down from there. That's usually pretty good for, that's the temp I use for pedal kits too.
And for more tips on soldering, we've got a lot of great ones in the instructions on page 16.
Yeah. Now you can see, since I didn't trim those leads below that, I need to just go in there and get those. Otherwise, those may touch ground. So you need to make sure that you trim those. If they're poking out and you can't get to them, loosen this screw. You can pull your board up and allow yourself a little bit better access. But I can get to them with my little flush cutters here. You're not going to be able to see on camera, and I apologize. But you can see that now those leads are trimmed. Those two leads there are trimmed short, and I'm just going to bend them up just a tad to make sure they're out of the way and they're not going to touch the chassis. And again, you could cut those in the previous step if you're worried about it. Shouldn't be a problem.
So would there be any issues if when you trim away those leads, you lose the little piece that you trim into the chassis?
You can shake it, see how much stuff falls out. Again, everything's pretty well secured at this point. You can use compressed air. There are some issues with using compressed air to blow things out of your chassis because you could blow things into a joint as opposed to cleaning out your chassis. But in general, you want to try to keep as much track of those leads, those ends of the leads as you can.
any little extra is going to be a possible troubleshooting step down the line. But again, I'm pretty happy with how that is. So we're going to move on.
All right.
We're going to solder our 6v6 socket. So we're going to get one of these two green leads that are coming through the board from our pilot lamp socket, carrying our 6.3 volts AC. That's our heater voltage. We're going to wrap one of them onto pin 2, and it doesn't matter which. AC doesn't matter. So what I'm going to do is feed it. I'm going to unwrap this a little bit so I can feed it directly down. I like to have nice 90-degree angles, as close to 90 as you can get. And again, this needs to go to pin 2 of our 6v6. I'm going to bend that out. And hook it. And I went to the bottom pin because we're going to add another green heater wire lead over to our 12AX7 tube. So we're basically just going to chain these all together. So our next part of this step is to wrap the other jumper onto pin 7. The other green jumper, sorry. I'm simply just going to bend that the other way. And I remember pin 1, so pin 8, pin 7. Looking good there. I'm going to go ahead and solder those right now. Looks good to me.
All right. And for anyone who may be joining us in the middle of the stream here, this is our episode 4, continuing our live build along series of the mini Tweed, 57 mini Tweed 5-watt amp kit. It's just one of 5 Icon series amp kits we have available. So besides the 57 mini Tweed, we've got a 59 Tweed 15-watt, a 62 Britplex 45-watt, a 65 P Reverb 15-watt, and a 66 D Reverb 22-watt.
Yeah. All classic circuits, and they're all great kits. They're all fun to build. They go up in complicated or difficulty, I guess, and they add a bunch more features. Obviously, this is as simple as it gets. The D Reverb and P Reverb have reverb and tremolo. And the JTM kit, the Britplex, is a nice high gain circuit, one of the first good high gain circuits.
Nice.
It's kind of the foundation for a lot of the more popular high gain circuits, at least.
All right. Can you show us what you just soldered there?
Yeah, so we just soldered pin 2 and pin 7 with our heater wires. And we are going to move on to the next part of this step. So what we're going to do is add 2 more green jumpers. Essentially, like I said, we're just daisy chaining the heater wire, the heater voltage onto our 12AX7 tube. You should have about this much green wire left. There's no length listed in the instructions. It needs to be long enough to get from your 6v6 over to your 12AX7 tube, which is about 3-4 inches. I like to just cut this in half. You don't need any more green wire at this stage in the kit. So why not use it and make your amp look good and sound good? So with this, essentially, we're going to make sure that we twist this tightly in the same manner that we twisted this first heater coil. What we're going to do is start about 1 inch or 1.5 inches in, and twist and twist.
Again, this twisting is not just for looks, it's for hum cancellation. The AC signals can create hum, kind of in the same way they create magnetism. And twisting these will do some hum cancellation, if you want to think about it, in the same way as a humbucking pickup. That's kind of boiling it down. But essentially, make sure it's nice and twisted. And as you can see, the twists are about the length from one tube socket to the other, which is what we want. And then I'm going to have these go 90 degrees down towards those sockets. So you want to end up with something that looks somewhat like that. Is that a good shot, Rachel?
Mhm.
Cool. And we're just going to wrap those onto the same leads. So we'll pull that insulation back, bend them out.
And so with this connection, or really with step 58 in general, we've got quite a few connections. Do you have any concerns regarding lead dressing?
Yeah, and we'll talk about the lead dressing once we solder them. You generally want to solder everything and then do your adjustment. You want to keep the AC voltage away from your signal, is the most important. So that's what we're doing essentially by creating this 90 degree that comes up off the tube. If these were just willy-nilly hooked in here, it would be harder to get them coiled right, and they would also end up closer to your signal, which is going to be tucked up over on the chassis as much as we can. So this is essentially step one of the lead dressing, is getting that AC up and away from where our yellow signal lines are going to be. So I'm going to go ahead and solder those two. And I'm sorry if you won't have a good shot of this one, Rachel.
That was actually,
This next one, yeah. I can barely see this, so it's just tough to get the camera a good shot. Just make sure you're inspecting your work, confirming every connection, and just double check. Because again, if this heater voltage doesn't get through to your 12AX7, then that preamp tube isn't going to be able to amplify your guitar signal because it won't have the proper heater voltage. Heats up the gas inside of that vacuum tube. Still not getting it. There we go. So that was a little bit stubborn. Still not quite as solid as I'd like, but I think we are good to go. Yeah. All right, so now I'm going to bend that out of the way so I can get the rest of my 6v6 connections. So we are on to eyelets, the jumper from eyelet 17, which is this yellow one, onto pin 4. So that is the one next to the green, which I'm going to go ahead and solder that, that blue rather lead from our output transformer. Just going to go ahead and solder that now. It's on there we go. Still not quite set.
And so what are you inspecting there that's giving you that indication that's not quite the way you want it?
Yeah, so a simple little tug test will show you that it's secured. So you can see, I burnt that insulation a little bit, not the end of the world. You can see that conductor is not going to pull away from that tube, which is good because this is what is
feeding the output transformer your final amplified signal that your transformer then turns into a low voltage, high current signal to drive your speaker. So this is essentially the last stop before your guitar signal comes out of your amplifier and into the transformer and speaker. So we're going to go ahead and add that yellow jumper. So you can see this short yellow jumper here is going to end up, pull that out. It's going to end up on pin 4, which is the next one next to this blue conductor that I just connected. So I'm just going to, as always, pull that pushback wire insulation back and wrap it onto pin 4. You can see that. It's poked.
A little bit more the other way, because there we go.
This guy right here, yeah. And I know there's a lot going on. So I'm going to go ahead and solder that one.
And so what is this connection?
This is your B plus supply for the 6v6 tube. So again, these connections right here, where your filter caps are supplying the high DC voltage that tubes require for proper operation. So I've got that one in there. Looks good to go. I'm going to tuck it just out of the way for tidiness. Again, there's no signal at this point except for that blue lead. So I want to keep it away from that blue lead. You can see that, Rachel. I've got my yellow lead away from my blue lead. We're going to connect the lead coming through 19 onto pin 5. It's our next part of this step. So again, pull that back, feed this down through that eyelet. And I don't know if you can see that past these green heater wires, but it's just wrapped through that eyelet. Same deal. Going to be a little bit of repetition since we're doing the same process kind of over and over. And that is essentially the input to the tube from your output driver stage of your 12AX7. So it sends the signal from your volume pot back to this tube, then from that tube up into your power tube. And then your power tube amplifies that signal even more and sends it through to the output transformer and speaker. So that's a good one to keep away from everything else, particularly the heater wires. And you can see I've done what I can to run it down and have it come up kind of on its own back there. All right, on to the next one. We're going to strip 3/4 of an inch of insulation off of our last lead that comes to the power tube. That is the one that comes from eyelet 20. So this is going to go through pin 8 and pin 1. So we need to strip some insulation off so that we don't need to make a short little jumper. So I'm just going to use regular wire strippers. Cut that insulation. There we go. And I dropped it, of course. Excess textiles in our amp.
So what is this connection, or I guess what is connecting to this pin, I should ask?
So this is your cathode. This is what sets the bias, which bias is the difference in voltage between the grid and cathode in a tube. So these two components are setting your bias, and then the cap is a bypass cap, which essentially makes your tube have a little more oomph, a little more output. A common modification, even from the factory back in the 50s,
was to add another one of these caps over here for your preamp tube. So this is the cathode resistor for your preamp tube.
That's a little bit too.
Yeah, and adding this cap, just another one of these in line with this in the same way, would get a little bit more gain even out of the 12AX7. So that's a really common modification that a lot of people do. And if you ever see some of these old circuits, I'd say 9 out of 10 of them have that mod done. So I'm just going to bend that wire so that when I feed it through, it will go where I want it to. And I'm going to bend the other end up. So now, so again, I'm just feeding that through so it connects both of these lugs here with the same wire. So we'll go ahead and get it done, and then I'll show you.
And just a reminder to everyone watching at home, we are live here so we can answer your questions. So please feel free to pose any questions you may have in the chat.
Yeah. Sassy Cat's been quiet today. So you can see I've got that fed through both of those lugs on these pins. I'm just going to go ahead and solder them, and we'll be done with our 6v6 socket.
Before we move on, we kind of glossed over it a little bit. You mentioned that connection from 20 to lug 8 and 1 is coming from your cathode, or setting the cathode bias, right?
Yeah, it's a cathode resistor which sets the bias for this tube.
I'm sure that it can get very technical. Is there a sort of simplified way that you can explain exactly what biasing the tube is doing?
Right. Like I said before, it is setting the difference, the voltage difference between your cathode and your grid. So then your grid is where the guitar signal, which is AC, is applied. So there's a voltage difference which controls the passive electrons. So if you apply an AC voltage to that control grid, the amount of electrons when the AC voltage changes phase will allow more or less voltage through, which is how amplification works in a tube amp.
Perfect.
And again, a cathode biased amp like this is one that has just a resistor controlling that bias voltage. And it's kind of the simplest way to do it. And it makes changing tubes easy because you don't need to adjust anything unless it's way out of spec, and then you'll need to swap that resistor out. But most 6v6 tubes in this amp, you could just swap it and go.
All right, that wraps up step 58, right?
Yes, it does.
All right.
So we're going to
Moving right
solder
along.
our output jack. If you'll remember before, we have our output jack wired to our output transformer, and we just need to add this lead to this lug and solder that all together. Did you catch that, Rachel?
Mhm.
We're just going to take this lead and solder it to the center lug. Depending on the placement of your board and your chassis, this may be a little short. In that case, you can rotate that lug or just make another jumper and add it after the fact. Not the end of the world either way. So, like I said, mine is a little short. So what I'm going to do is rotate this lug, which is a simple affair.
And
Loosen
while you're loosening that, Sassy Cat does have a question for you.
nice.
How difficult would it be to make a combo amp with nanotubes, if possible?
I mean, if you have the capacity to solder on that level, you could do it. I think if I'm following, she means the little tiny tubes that are in some guitar pedals and some modern PCB amps. Certainly a possibility, but we sure don't have a kit for it.
And for those who might not know, what exactly are nanotubes?
They're tiny tubes. They are, smaller than a fuse. And essentially, the idea is that you can put them in a much smaller enclosure and still get tube amplification. And again, I don't know exactly what the allure of a nanotube would be in an amplifier. Like normally they're used in smaller applications. Like there are some new pedals that use nanotubes. But it's an interesting question.
Yeah, thanks, Sassy Cat.
I'm just having a little bit of a hard time getting this lead fed through here. So just bear with me, folks. Again, we're live. There we go. And again, depending on the placement of your mounting holes, this may be a lot easier. So I mounted this board. I could have mounted it, maybe an inch or two further. Another thing you could do is cut that lead longer. If you haven't already done this kit, I'd recommend making this lead, maybe another ½ inch longer, because as you can see, we have plenty of yellow left over that came with the kit. So fighting with this one isn't entirely necessary. I'm going to bend it over and do my best to get it soldered and move on.
All right. Let me see if I can find that step that 21 gets added.
Yeah, either way, it's not the end of the world. But if it saves you a little bit of trouble, it'd be good if you can do it ahead of time.
Yeah, it looks like that would be step 38. So just a quick note, if you watch through these and then go back to start your build, it says to make it 1.5 inches. You'd probably be fine making it 2 inches.
Make it 6 inches and then cut it to length. Seriously, there's probably a foot of wire at least left. So I'm just going to double check that, because that's a really important connection, and it was short. So I just want to be sure it's good. Looks good to me. I'm going to go ahead and cut the extra and move on. We're done with our speaker jack.
All right. Sassy Cat had a quick follow-up comment. They asked because there are reports that classical vacuum tubes will be banned from being used in the U.S. in the future. Have you heard anything about this, Tommy?
No. And I would be surprised if they could ban the use of vacuum tubes.
All right. So that is...
That's the end of step 59.
Right. So moving right along, we are now on page 24 of the instructions.
Yep. So from eyelet 22 to pin 6 of our 12AX7 preamp tube socket. If you remember, these tubes have 9 pins, so they're symmetrical, but there's a gap. And that gap is where pin 1 is, pin 1 and 9. So clockwise, 1, 2, 3, 4, 5, 6, 7, 8, 9. The instructions have you load these in the most logical order as far as getting in your own way. So we're going to add the eyelet the lead from eyelet 22 to pin 6 of our 12AX7 socket. Oh.
And so what is this jumper from eyelet 22 doing and going into this pin 6?
So I believe this is a cathode resistor? Load resistor? But I could be wrong. Let me look again. No. This is essentially the output of the second stage
of V1, your 12AX7. So a 12AX7 tube has two halves that are essentially the same, and each one in this circuit are amplifying your signal. They're responsible for a lot of the gain you get out of this circuit, that is breakup. So this is what sends the signal from the second half of your V1 tube, which is also called an output stage driver, and sends it into the power tube. So if we were looking at how the signal flow went, it would come up from your input jacks to your tube, then through this coupling cap or blocking cap to the volume control, then from the volume control back into the tube, and then through this lead we just did out to your power tube, which then amplifies it again.
All right.
Kind of simplifying it, but more or less that's how it works.
Sure.
Now from 23, we're going to wrap that to the pin 7. So that's our lead that we marked with black, and pin 7 is just the next adjacent pin right here on your 12AX7. And you'll just peel it back and feed it through.
While you're getting that in place, we are getting a couple more questions. Lassie Johansson asks, do you mind if I ask how the do-it-yourself Tweed amp differs from the Fender Custom 57 Tweed amp?
You build it yourself. I'm not sure if that one is hand wired, but it's probably the same circuit. I'd have to look at the schematic for that particular amp, but this is the 5F1 circuit. And the main difference between this and a store-bought amp in general is this is a hand-wired amp. Most amps out there nowadays from the big brands are not hand-wired. They use printed circuit boards. Again, I don't know that circuit in particular, so I can't say whether or not it is or isn't, but that is the main difference for most production amps from this one. So you can see I'm pushing this lead away and down into the bottom of the chassis. Can you see that, Rachel?
Oh, yeah.
That's what we want. Again, this is a signal lead that is carrying an amplified signal. Any noise introduced can just get amplified again and again and again through on out through the circuit. So we're done with that one. We're going to get the jumper from eyelet 12 coming through hole 23. So that's the one that's not marked on that same hole. We're going to wrap that onto pin 8. Should be approximately the same length and exactly the same procedure.
And we've got another question here. Craig Haver asks, is there a health issue to worry about handling the lead soldering wire or from the smoke from using lead solder?
I mean, if you have underlying health conditions or if you're not in a well-ventilated place, I would wear some type of ventilation mask. You do end up with a fair amount of solder smoke in this when you're building this kit. They sell lead-free solder. I don't recommend it, but if that is a consideration for you, that is certainly an option. I just find the lead-free stuff doesn't make quite as good of a connection. Mm-hmm. And again, handling it, I'd say you're not at very much risk there.
All right, so I guess it comes down to how much soldering you're doing. If you're just doing this project alone and you're not soldering day in and day out, you're probably not going to be inhaling very much lead at all.
Right. So we are on to one of the green jumpers from the 6v6 socket. Doesn't matter which one. We're going to connect that to pin 9. So I'm going to get this pulled over here. And doesn't matter which one of these, like the instruction said. I'm going to peel that back. And I'm going to bend it down so it can feed in to pin 9. And again, pin 9 is my last pin on this bottom row. Can you see that, Rachel?
Oh, yeah.
So that's our heater. That's one of our heaters for this 6v6 or for the 12AX7.
And so a big difference between this 12AX7 socket and the other two, the 5Y3 and the 6V6 socket, is there's only one eyelet on each pin.
Right,
rather
but they
than
are
double.
nice and big, as you can see. For this circuit, there's no pins with multiple connections.
I think we're not supposed to solder this one yet, right?
We're going to solder this one.
Oh,
You messing with me, Pete?
no, I think you're messing with me.
That's the only connection at pin 9, so there's no problem soldering it. Again, the other one goes to pin 4 and 5. Now, instead of stripping this back and wrapping it through, which is a possibility, we're going to bend these pins together. So this wire is stiffer, and these pins are a bit more delicate than the big beefy pins on these. Bending this around can be difficult in this short space here. So what I'm going to do is simply bend those two into shape so they kind of can pinch together. So what I'm going to do is grab wire strippers, bending pliers, whatever you've got. I'm going to use a pliers, needle nose here. And I'm going to grab those pins and twist them. So if you can see that, Rachel, cool. I'm going to twist them.
Is that green on them? Oh, yeah, that green.
So I twisted them so they're kind of facing each other, and then I can kind of pinch them together so that it'll be much easier to get that green lead fed in between them. All right, I like that. So again, I'm going to get that green lead peeled back. I'm going to put a bend in it so it feeds through there in the way that I like. And pull that through those connections. Sorry, there's not a great way to get a good shot of this. But you get the idea. We're going to feed that lead through both pin 4 and 5 of that 12AX7 socket. Easier said than done sometimes. There we go. So part of why I think it's a good idea to solder that other pin is the amount of moving around I had to do on that. I don't want to have to go back and redo that one after. I will give it a little tug test to make sure I didn't break that solder joint when I was squinging that thing around, but we should be all good to go. So again, just go ahead and solder that. Make sure you solder both lugs. I'm going to get it just a little more solder on that one. Again, this tube is not going to work at all without proper heater voltage. So that really needs to be a good connection. Use my chopstick to pull on those. Oh yeah.
Oh, you need to tilt that.
Yeah.
So you can see.
Yeah. So we've got, I'm putting good amount of pressure on both of those sides, and we're good on both of them. Pin 5 isn't going anywhere either. And I've got my good 90-degree like I like. So we are good on the heaters.
Nice.
We're getting very close now. Just got 3 more connections for the 12AX7. So we're going to get the jumper from eyelet 24 to pin 1. Again, the one adjacent to the gap on that no-volt socket. It's not behaving. So again, if you're having trouble with the pushback wire, you can strip it back using a wire stripper if you like. I like to leave it just because I feel like I can get a cleaner look rather than having tattered cloth in there. But it's absolutely up to the builder. So I've got that wrapped onto pin 1. Again, I'm not worried about lead dressing until after I solder. Speaking of solder, there it is. So I'm just going to get in there. Tin this tip. That's better. You can see that it's on there nice and solid. Now I'm going to dress that one. I'm going to push it down into the bottom of the chassis, kind of just like these other ones. If you can follow the same general shape, you should end up with a nice tidy looking circuit at the end. Next one is going to pin 2. That is our through hole 25. This is the one that feeds the guitar signal from the jacks through those resistors directly into the tube.
Can you tilt it a little bit more?
Yeah. So again, this is the connection from your guitar strings to the amplifier. Super important. And if this one picks up noise, either from getting too close to the heaters or some other problem over here, it's only going to get amplified more and more. So this is a really big one to make sure it looks right. So you have a nice quiet circuit as far as noise. So I'm going to solder that one. Give it a little tug. Looks good. I'm going to moosh it out of here, back in the corner.
And again, for anyone who may be just joining the stream, this episode is a little different since we're working in such a confined space. So we'll try and tell you exactly what we're going to do. And then after we've soldered it or, put it into position, then we'll go ahead and show you what we've done, just to reiterate that.
Yep. And our last part of this step is to connect that cathode to pin 2. Pin 3. Larry's rides here. So again, just get that into that pin and then we'll worry about dressing it once we solder it. I try not to put too much stress on these 12AX7 pins because they are a little bit more delicate. If you ever run into a problem, like if you melt a component or if something just doesn't seem right or is broken or whatever, you can always email StewMac.com, service@StewMac.com, and we'll help hook you up, whether it's a replacement part or what have you. And so this one, I'm just going to wire out like that. So that is good to go.
That's the end of step 61.
That's the end of step 60.
Oh, absolutely.
So now 61, we're going to
Getting ahead
add
of
our
myself.
power cord and strain relief. So I'm going to spin this back around. We are done with all the connections for our circuit aside from the main power that comes in and is wired in to our fuse and our control knob / power switch. So I'm going to go ahead and grab that power cord. This is our strain relief if you want to get a shot of that, Rachel.
And Tommy, I believe we did find some differences in the length that you would recommend cutting this.
Well,
to,
yeah,
right?
there's a discrepancy in step 61, where you add the power cord and strain relief. And again, our power cord's nice and long, 18 gauge stranded wire, good for amps. There's a discrepancy where it says pull back 7.5 inches of this black jacket so that you can get to the 3 leads inside. Then it says 9.5 later. So what I find is 9.5 is the right amount of jacket to strip back off of this power cord. Like I said, it's nice and long, a lot longer than any vintage amp would ever have had. So it's another great little tiny minuscule tweak to make this modern version of this classic vintage amp more user-friendly. So again, you don't need to measure exactly, but if you get somewhere in the neighborhood of 9 or 10 inches, that is what I would recommend as far as peeling back this black jacket. It allows you more flexibility routing the rest of your wire inside the chassis. And you can always cut them to length, but it's hard to get them longer.
And so what should everyone building along here be cautious of when stripping that insulation?
So go gently, go slowly. Try to break it. Don't try to cut all the way through it because these inner conductors are very sensitive. The jackets on this green, white, and black are not extremely thick where this black is, this black outer jacket. So it's really easy to nick those, create a possible short. Just take your time and go incrementally instead of trying to cut it all at once. Like I said, it's best if you can break it, like by bending it, you can break that hard, stiff plastic and avoid cutting these inner wires. So what we're going to do is get that chalky stuff off of there. We're going to pull that power cord through our hole in the bottom of the panel with the tubes, which is going to be the bottom panel once the amp is installed, once the chassis is installed in the cabinet. And you can see in that bottom corner, it's pretty tight. So you don't need to have too much of this black jacket going through. But the black jacket is going to protect the inner conductors from this metal chassis. And we're also going to add strain relief in case your amp ever gets yanked by the power cord or anything like that. Just a little added peace of mind so you don't end up pulling it out and having to repair it. So this strain relief can be a little bit tight. The way it works, you want the bigger lip on the outside. And then this little clip folds in there. There's a little piece of plastic that holds that clip in place. It just helps it so you don't lose it. What you may have to do is pinch this strain relief with a pliers or something. I find often I can force it in, but you may need to grab some type of needle nose pliers because you can see it's having a hard time getting through because it's nice and tight, which is what we want. If that thing was loose, that power cord could just slide right out. But with that tension on there, it's going to hold it. So you can see it took a lot of force to pull that out. So what I'm going to do is pull that back out and just get it reattached again. But you can see it does do a good job securing everything in that mounting hole. And again, it's just in case of, in worst case scenario, your amp gets yanked or falls off a table or something. It's going to protect it. It's going to protect that power cord from getting damaged or pulling out of your amp. Just get that back in there.
We've got an interesting comment here. Kevin Oldman says, I use these screw-on cable gland things. Is that, I'm not familiar with them. Is it some kind of other cable secure, I suppose?
Yeah, there's a ton of different styles of these. There's also strain relief inside the cabinet. Just extra peace of mind for anytime your amp takes a spill or somebody trips over the cord or anything like that.
Right.
Of course, it went in perfectly the first time. It's giving me trouble the second time. We'll get it in here. We'll move along.
Right, this is what happens. We are live here. So again, please feel free to continue to send us your questions in the chat. We'd be happy to answer them.
Absolutely. There we go. So we're good there. The rest of the step is trimming these back to the lengths we want. So with the black lead is going to be 5 inches. I actually recommend you go a little bit longer. I'd say maybe 6 inches, 6 or 6.5. What you want to do is connect it to the fuse socket. So what I do is get it wired how I'd like it to be in the end, which is along this side wall, and then following these other AC connections up here, and then down to the fuse socket. So instead of just cutting it to a length, I like to kind of mock it up first. Then I can check and make sure it's exactly where I want it to be before I cut it and end up too short or having to sacrifice some of the aesthetics that I'm going for. So again, this isn't pushback wire. You're going to need to trim this with a wire stripper. It's 18 gauge. It's stranded wire, and it's not tinned. You can tin it if you like. Not entirely mandatory, but I'm going to go ahead just to make it a little easier. Just a small amount of solder on the end will help it make a quick, secure connection with our tab on the fuse socket. The fuse socket tab is going to spin until you have your lamp in there. Nothing to worry about. And I'm going to go ahead and make a nice solder joint there.
So although this isn't pushback wire, it looks like it's stranded. Is it pre-tinned?
No, it's stranded copper wire. And again, there's nothing too special about this power cord. You could find one of these at any hardware store. You could cut the end off a common power cable and find the same thing inside. But what's nice about this is it's nice and long, so that you don't have to have your amp right next to an outlet. So I'm going to go ahead and trim that extra lead there poking out and move along to the white and green wires. The white wire goes to your power switch / volume control. So I'm going to do the same thing and just mock that up. It says in the instructions 9.5 inches. That may be dead on. It may be too short or too long, depending on your specific wiring and routing. But what I'm going to do is just mock it up and send it over the same way and the same direction that I sent this other black lead to this volume pot and switch. I'm going to follow that same route with my white. Ideally, it'll be just the perfect length. And if not, no one will know but you. So that's pretty good there. What I'm going to do is strip that back and tin it and solder it. And then I'm going to adjust my lead dressing.
So Tommy, is there anything people should be aware of or cautious of when soldering or tinning that, preparing that connection over top of the board? Is there any kind of danger of damaging the components or anything?
Very minimal. If you drip solder on the board, it's good to clean it up. But there's really very low risk that you're going to actually damage anything. You may scorch a component if you're not careful with where your iron is. Some of these taller components, if you ding them, you'll melt some of that plastic covering. But it's really not likely to damage the actual components or cause any problem in the actual amp circuit. So you can see I've got my power and I fed it through in the same way, if you can see that, Rachel, in the same way as this other black lead, and then came under here, So I'm away from these signal lines. Super important stuff. So we're done with that one, and all we have to do now is get our ground connected, and we will be set. We will be all wired up. So this ground one can be as short or as long as you want. It's just got to get down onto that terminal strip in the very bottom of your amp. You can do this one first if you want. Not super important because you can just push this stuff out of the way. And I can see I have access to that last lug. If you can see that, Rachel.
Give me just a second. There we go.
That last lug there is where I'm going to go with this green lead. And this is your main safety ground. Really important so you don't get any nasty unexpected shocks or anything like that in case you're working in a shady venue.
And I should have mentioned before now, when we started making these connections, we are now on to step 62, which will be our final step for this episode.
Yep.
While you're making that connection, Sassy Cat has another question for you, Tommy.
Shoot.
Would you happen to know what function a 6C10 tube serves in their Super Champ?
It's probably a power tube. 6 is the heater voltage. C is a function or another kind of classification. And then she said a 6C10.
Yes.
Off the top of my head, I forget what the 10 is. We could look that up, but again, you could probably look at a schematic and figure it out. Generally, if there's a number, like if it says V1 or V2, that's a preamp tube. And if it's later, one of the later tubes, like one of the last couple tubes, it's probably a power tube.
Let's see what you got that.
Can you see that?
Can you turn it a little bit more towards me?
Yeah, I'm just afraid that'll jump out. But
Yeah, there we go.
so I've just got it wired down in the eyelet. I'm going to solder it real quick, and we will be finished wiring our circuit. It's a big joint, big thing, everybody. Everybody give yourself a hand if you're building along. We just wired an amp.
All right. Yeah, that wraps up today's episode.
Yep, we're looking pretty good. I'm going to go through and just tidy up a little bit, but we're ready to wrap it up. And next episode, we're going to get into testing and plugging in the tubes and making sure everything's right. And then we're going to let it rip live on YouTube.
Right. So for now, this is a perfect time if you are building not along, but using these videos as an instruction. It's a great time to take a break and make sure you're not overly tired. But I guess until next episode, please join us again. I'm Pete. I want to thank Tommy Stumpp.
Yep. Thank you, Pete. Thanks, Rachel.
Wow.
And thank you, Susan.
Thanks, Susan. Our excellent
Please,
director.
please come back for our finale next episode. Like Tommy said, we're going to be testing it live. You know, fingers crossed, everything should work out great, but it's kind of the tension of doing this live. So we'll be live again, 3 p.m. Eastern, Monday, December 21st. And please, we'd love it if you join us again. Oh,
Absolutely.
one last thing. Please feel free to leave any questions in the comments for this video. We'd be happy to address them at the beginning or sometime during episode 5. Probably aren't going to have that opportunity again after episode 5 since it's the finale. But we did receive an interesting question in the comments of episode 3. It was from Joe Thornhill. Wanted to know how far apart are Tommy and I actually. If that's an actual studio behind me and not a green screen, then it looks like a totally different room in a different part of the shop. So Rachel, can you give a little peek behind the screen?
Sure.
Let the audience see us.
Right there.
Hi, Pete.
Hey, Tommy.
All right, y'all.
All right. Again, thanks everyone for joining us, and we'll see you next episode. Have a great night.